In this part of the lecture, we're going to talk about the speech production systems. This will be a very brief overview since this section is not, we're not in the anatomy and physiology class, but I do want you all to have a brief overview of the different systems involved in speech production. And a great deal of this information will be covered in my anatomy and physiology class for those of you that have already taken the 4037 or are taking the 4037 this semester as well. There are four systems involved in speech production: the respiratory system, the phonatory system, the articulatory system, and the central nervous system or the brain. Now, as part of this lecture, we will only be talking about the respiratory system, the phonatory system, and very briefly about the nervous system or the brain. And Mrs. Basham, during her section, will be talking to you about the articulatory system, because as part of the phonetics course, you're going to talk about the articulators, the placement of articulators, the manner of articulation, and things like that. So you will cover the articulatory system in great detail with Mrs. Basham. Um, why? Why is that we want to know about the speech production systems when we are taking a speech science or an acoustics course? It is important because our focus is of this semester is to understand how speech is produced. And as part of the acoustics course, we're going to talk about vowels and consonants, which are part of our speech production system. How do we produce vowels and consonants? More so, what are some things that we identify with the vowels and consonants in my section? So the production part of vowels and consonants will be in Mrs. Basham's section of the course. So we're going to continue today, and we're going to talk about the systems involved in speech production. Again, we're going to focus on the articulatory system. I'm sorry, we're going to focus on the respiratory system, the phonatory system, and briefly about the brain. Okay. So, what is our goal in speech production? Our ultimate goal in order to produce our final output, the speech, is a meaningful combination of sounds. Now, if I want to say the word cat, I want to say ka, t. I have to combine the ka, and t in a certain sequence, and it has to be using certain structures, certain articulators to produce that sound, if it involves a vibration of the vocal folds or no, and how much respiratory support do I need in order to produce that sound or the word cat. So, in order to produce a speech sound, what is involved? I need air, that is the source, that helps me vibrate my larynx or the vocal folds, which is my source of vibration, and then that air is regulated by the articulators in order to produce speech sounds. If you've heard my first lecture terminologies, or if you've looked at my anatomy lecture, I always bring this example that if I have the respiratory system and I have my phonatory system, if I remove my head and kept it on the side, right? And if I were to just make this, if my air was from my lungs was supplying to the vocal folds, all I would hear is bzzz, bzzz, bzzz. That's the sound. Now, but that's not what we hear or what you hear as I'm giving you this lecture. My speech has a lot of speech sounds. Speech sounds include vowels, speech sounds includes consonants. It also involves in the way I communicate this information in terms of pitch, my inflection, which is in terms of frequency, or my intensity and stress patterns, right? So, I need my articulators, that is above my vocal folds, in to modify that sound that comes from my vocal folds into specific speech sounds. And that part of this course, the phonetics and how speech sounds are produced, is taught by Mrs. Basham. She's already talked to you about the anatomy of the articulatory system, and she's gonna talk about how the different sounds are produced. And speech science will involve how to identify these speech sounds based on the terminologies we've been talking about so far. Okay, so the focus of this lecture is I'm going to talk about what is involved in our source, the air, and what is involved or what system produces the vibration to make that bzz sound, and then that sound gets regulated by the articulators. That's not the focus of this lecture. How do we achieve what we need to achieve? We need to contract our muscles. There are different muscles involved in each of these systems, and shortly we'll talk about the muscles involved in the respiratory system and muscles involved in the phonatory system. So, the main controller is our brain. The central nervous system, our brain, is going to send some impulses through nerves to our muscles that are involved in respiratory or phonatory system or articulatory system, the muscle contracts. The muscle has to contract for a certain duration, has to contract with a certain force to be able to produce our meaningful output or speech sound. All right. So the four systems that are involved in our speech sound production is the respiratory system, which provides us an air supply. The phonatory system, which is a source of vibration. Our articulatory system, which is required in shaping our sounds into specific phonemes. And of course, the nervous system, which is our key controller. So if you have observed anybody that has had a stroke with the left hemisphere that is being affected, sometimes the left hemisphere will not be able to communicate what the sound needs to reproduce to the rest of the systems. Your central nervous system is your controller or the central system. Your respiratory, phonatory, and articulatory system are your peripheral systems. So it is in the periphery. So the brain is affected. Even if your peripheral systems, respiration, phonation, articulation are fine, it's not going to be able to produce our speech output. On the other hand, if your brain is fine, if somebody has had issues with the phonatory system, or if somebody had an articulatory system issue, meaning if somebody had a cancer of their tongue and if half of the tongue had to be removed, then it's the peripheral system that is affected more than the nervous system. So you get the distinction how, but all of these systems need to work in coordination to produce our final output, that is speech. Okay. So now let's talk about our respiratory system. What is respiration? Right? Respiration is the exchange of gas within an organism. You will breathe in oxygen, you want to breathe out carbon dioxide, and that's just something that we all do. It is an automatic process that you don't have to think about while you're breathing. Okay, it's an involuntary process. It's controlled by the autonomic nervous system. So how does speech play a role in this? So speech becomes an overlaid function of exhalation. So respiration has two processes, an inhalation process and an exhalation process. Inhalation means you're breathing in air, and exhalation means you're breathing out air. Now, speech is a function of exhalation. So when I am talking, I quickly breathe in, but I'm talking when I'm breathing out. That is why it is called an overlaid function of exhalation. So let me demonstrate this. I'm taking a nice breath and I'm going to phonate ah. Okay, so I go ah. So I took a quick breath, but I could phonate for long on my exhalation. I want you to try this exercise at home. I want you to put your hand on your belly and I want you to breathe in. When you breathe in, your abdomen, your belly needs to go out. And then I want you to phonate ah, and you can observe as your hand will go in when your belly goes in. So I will repeat it to you again. You can't see me, but all I'm doing is I'm placing my hand on my belly and I'm taking a breath in. Ah, and I'm breathing out and I feel my belly going inside. I want you to do this activity as you are listening to this lecture at home. So speech basically is a result of the modification of airflow from the lungs. So your lungs is your main source. We breathe in, we breathe out. We use that air that we breathe in or the supply from our lungs. It needs to build some pressure below our vocal folds, which is called the subglottic pressure. And I will talk more about it when we talk about the phonatory system. And you use that airflow to produce our speech sound. Okay. So, what is the anatomy of our respiratory system? When we talk about our respiratory system, we will be talking about the skeletal framework of our respiratory system. We will be talking about some of the muscles involved in inspiration or inhalation and expiration or exhalation. And then we will be talking briefly about what is the difference between quiet breathing and between speech breathing, which is what is important for us because we use a lot of speech breathing while we produce our speech sounds. So what entails our skeletal framework of the respiratory system? So if I move over here, I'm going to talk through from the slide here. Our skeletal framework involves four structures basically. Okay, the first is the rib or the rib cage that you see right here, the ribs. Then you have the sternum and the rib cage. So kind of you can put those two together. This chest bone, central bone right here is called the sternum, what you marked here. Then you have the pectoral girdle, which involves the clavicle and your shoulder blade, the scapula. So you have the clavicle right here and the scapula right here, which forms your pectoral girdle. Then you have the pelvic girdle, which is right here, which involves an upper broad bone called the ilium, a lower small bone called the ischium, and the connection between the ischium is going to be the pubic symphysis. And the final structure of our skeletal framework is going to be the vertebral column. Okay, so let's reiterate. Your skeletal framework involves your rib cage, the sternum right here, the chest bone. Your pectoral girdle involves your clavicle and your scapula. Your pelvic girdle involves the broad bone, the ilium, the small bone, the ischium, the connection between the pubic symphysis, and your vertebral column right here. Now, if you talk about these structures right here, let's look at each structure. The vertebral column has different different kinds of vertebrae. There are mainly 5 kinds if you see the names right here. There are 7 cervical vertebrae, there are 12 thoracic vertebrae, there are 5 lumbar vertebrae, a sacral vertebrae, which actually is a fusion of the sacral vertebrae. And then you have coccygeal vertebrae. I lost my mouse. There you go. The coccygeal vertebrae, it's a fusion of 3 to 5 vertebrae together called the coccyx. Okay, so you have the cervical, thoracic, lumbar, sacrum, and the coccyx. All right, that forms the vertebral column. The vertebral column is very important because it serves as an attachment for a lot of muscles and also for the ribs. If you see, all the ribs here are posteriorly attached, posterior meaning to the back. When you view to the back, are attached to the vertebral column. The vertebral column is also important because your spinal cord actually goes through your vertebral column. Okay, and right there it goes in between, there is a space between your vertebrae, and it goes through the vertebrae, the spinal cord. The cervical vertebrae, the first 2 are also important because the first one is called the atlas, which actually holds the skull, and the second one is called the axis, which helps us rotate the skull. Okay, so atlas is your first cervical vertebrae, and axis is your second cervical vertebrae. Atlas helps in holding your skull in position, while your axis helps in rotating the skull from side to side. Okay, now so we finish this vertebrae. The next part we're going to talk about is your pectoral girdle, which, as I said, has the clavicle and the scapula. It also acts as a point of attachment for lots of muscles. Then you have the sternum right here. The sternum has 3 parts. The upper part, where the clavicle is attached, that you see here, the right broad structure, that's called the manubrium. Okay. Then this structure that you see right here is called the corpus, or the body of the sternum. The small tailbone kind of thing that you see right here is called the xiphoid, or the ensiform process. I know I'm going a little bit fast over here, but your previous slide here has all of this terminologies that I'm talking about. We talked about the vertebral column, we talked about the pectoral girdle with those 2 structures, then I talked about the sternum so far, right? I want you to follow along, and as I'm saying, I want you to take notes, okay? I just want you to basically understand what are the systems that are involved in order to produce speech. So this is just a brief overview. It's not an anatomy class where I go into depth. And if anybody is interested, who are not in my anatomy class, I know most of you are in my A&P class and will get to view these in detail. But if somebody is not in my anatomy and physiology class and would like a detailed version of the respiratory and the phonatory system, please send me an email and I can give you access to the links where you can view the videos that gives in-depth information about these structures. Okay, so the sternum has the manubrium, the corpus, the xiphoid, or the ensiform process. Then we talked about the pelvic girdle, which has the broad bone, the ilium, the small bone, the ischium, and the connection between the 2 is the pubic symphysis. Now finally, we're going to talk about the rib cage. You can see how the ribs are attached posteriorly to the vertebral column, but anteriorly they're attached to the sternum. There are 12 ribs in total. The first 7 ribs are called true ribs because of its direct attachment to the sternum. The ribs 8, 9, and 10 are called the false ribs, or the pseudo ribs, because it attaches through the costal cartilage, as you can see right here. And then finally, the 11 and 12 are called the floating ribs, meaning they have no attachment to the sternum at all. Okay, so the information you can see right here, 1 to 7 are true ribs, 8 to 10 are false ribs, and 2 floating ribs, which have no attachment to the sternum. So that in sum is a skeletal framework of the respiratory system. So we have four structures: the vertebral column, the rib cage, the sternum. We have the pectoral girdle, the clavicle, and the scapula form the pectoral girdle. And the pelvic girdle is this bottom broad bone or the hip bone that we call, which you can feel. All right. The next thing we're going to talk is the respiratory passageway. So there are some structures that are involved in passing the air from your nose to your lungs. Okay. So in the respiratory system, where is the start of the respiratory passageway? The respiratory passageway starts with trachea. So if you look at this structure that you see on top is your larynx, which is the phonatory system, and I will talk about this later. But if you see starting from here through down here, these cartilaginous rings that you see is the trachea. This trachea is closed in the front and it's actually open in the back. It allows for contraction and expansion of the trachea to allow the passage of airway. Okay, so that's the trachea. The trachea at this junction right here, which is called the carina, C-A-R-I-N-A, carina, splits into the right bronchus right here and the left bronchus right here. This bronchus further splits into small secondary and tertiary bronchioles, and then they end up in small air sacs called the alveoli. And then the lungs sit on top around this. Okay, and that ends your respiratory passageway. So your respiratory passageway starts with your trachea. It branches out at the junction called the carina to the right and the left bronchi, and then these bronchi end up branching out into secondary and tertiary bronchioles, and these bronchioles end up in small sacs, which you don't see here, kind of end up in small sacs. There are about 300 million air sacs in your lungs, which are the alveoli, A-L-V-E-O-L-I, which is where the gas exchange takes place, right there, what you see, alveoli. Okay, so that is in sum where your air passes through from the trachea to enter into the lungs, and the alveoli are small gas sacs or air sacs where gas exchange takes place. Okay, so that is in terms what you want to understand briefly about the skeletal framework and the respiratory passageway of your respiratory system. Now, these systems are very important because we need the air. As I said, your respiratory system is the supply of air required for speech production. So you need to be able to produce the speech sounds, and you need sufficient air supply for that. There are certain muscles involved in respiration which also helps in this process. Now, one thing that I want to clarify before we move into the muscles of respiration is that for quiet respiration, meaning where you're sitting down and breathing without talking or without doing any physical activity, but as you're listening to my lecture and just breathing quietly in and out, the only muscle that contracts for this breathing is your diaphragm. This big muscle that you see right here, that's your diaphragm. But for expiration, it's a passive process, meaning you are not using any muscular work to breathe out. It's called the passive recoil forces or the elastic forces of your tissue that is inherent to those tissue to let the air out. So for example, if you think about a rubber band, you stretch the rubber band as long as you can. And then if you let it go, it goes back. You don't need any effort to stretch it. You need effort to stretch it, but you don't need any effort to bring it back to its original position. Similarly, for quiet respiration, you need a diaphragm, this muscle that you see right here, a dome-shaped muscle that contracts, it pulls down and increases the vertical dimension of the thoracic cavity. When it does that, and when you have to breathe out, you're just using gravity and passive recoil forces to breathe out. Okay, that is quiet respiration. So the muscles of breathing in, inhalation or inspiration, the primary muscle is your diaphragm. Right here, this big muscle that you see is your diaphragm. It has attachments to the vertebral column, the sternum, and the ribs. It's threefold attachment: the vertebral column, the sternum, and the ribs. Excuse me. When this muscle contracts, it pulls down the vertical dimension, pulls the thoracic cavity down by increasing the vertical dimension of your thoracic cavity. Okay. Another muscle that is a muscle of inhalation, which is important for speech, is external intercostals. This muscle that you see here is the external intercostals. It has connections from the lower surface of the upper lip to the upper surface of the lower lip. It has a diagonal kind of orientation. It goes between the 12 ribs. So that is external intercostals. And what it does is elevates the rib cage. So it increases more dimension in wanting air to come inside. So that is a muscle of inhalation. A muscle of exhalation that we will talk here is internal intercostals. Okay. This internal intercostals is beneath the external intercostals and it's in opposite direction to the external intercostals. What it does is it depresses the rib cage. If it depresses the rib cage, it forces the air to go outside. Okay. In order to understand how air comes in and it goes outside, we need to understand the relationship between pressure and volume, right? If pressure increases, volume decreases. If volume increases, pressure decreases at a constant, gas temperature. So you want to understand that pressure and volume are reciprocal to each other, and that phenomenon is called the Boyle's law. Boyle's law is stated as at any given gas at constant temperature, pressure is inversely proportional or reciprocal to volume. Okay. So those are some of the primary muscles that we've seen so far. Diaphragm, which is actually the very primary muscle for inhalation. We talked about external intercostals. And for exhalation, we talked about internal intercostals. But there are other accessory muscles of inspiration and expiration. And we will talk about these right here. The accessory muscles of respiration include muscles for inspiration and muscles for expiration. The muscles of inspiration include two neck muscles, the sternocleidomastoid, which origins from your mastoid and comes in, attaches to the sternum and the clavicle. And then you have, let me find a better picture, right there. The other neck muscle, which is the scalene. The scalenes are anterior, medial, and posterior scalenes. So the two neck muscles are the sternocleidomastoid and the scalenes. Then the other muscles of inspiration involves this broad chest muscle right here, which is the pectoralis major. And then a minor, pectoralis minor, which is beneath the pectoralis major. Okay. Then you have the other muscle which involves the serratus post anterior, which I think is right here. Yes, the serratus anterior is another muscle of inspiration. And then you have serratus posterior superior, which we saw right here, serratus posterior superior, and the latissimus dorsi, which is a back muscle. So the back muscles involve the serratus posterior superior and the latissimus dorsi. These are the muscles of inspiration. So the accessory muscles of inspiration include the sternocleidomastoid. Then you have the scalenes, which is another neck muscle that you have, the anterior, the medial, and the posterior. Then you have the serratus anterior right here. Then the two back muscles involve the serratus posterior superior and the latissimus dorsi, which are muscles of inspiration. And you have the chest muscle, the pectoralis major, and beneath or underneath the pectoralis major is pectoralis minor. All of these are muscles of inspiration. Okay. Then the other muscles of expiration, we've only talked about the internal intercostals. The other muscles involve the abdominal muscles. Okay, which we see right here. If you have heard of the six-pack, right, that's nothing but the rectus abdominis. You see, it's bilateral. So if anybody has a six-pack, that's that muscle that gets displayed as a six-pack, the rectus abdominis. Then you have the transverse abdominis. Then you have the external oblique and the internal oblique. These are four abdominal muscles which helps in expiration. It compresses the abdominal cavity in order to expel the air out. So those are the abdominal muscles. The other muscles of expiration include your serratus posterior inferior that you see here, and the one that is not, I don't have a picture here, is the quadratus lumborum. Okay. The abdominal muscles include the rectus abdominis, which is your six-pack, the transverse abdominis, the external obliques, and the internal obliques. All right. Then you have the quadratus lumborum and the serratus posterior inferior. So far, what did we talk? We talked about the goal in speech production being how do we get to articulate those speech sounds. We need the prerequisites include a air supply from the lungs, a source of vibration in the phonatory system, and modification of that sound that comes from the phonatory system into distinguished speech sounds. So in this lecture, we're only going to talk about the respiratory system, the phonatory system, and to some extent about the central nervous system, the brain. And then we talked about the respiratory system. We discussed what respiration is. We also talked about the skeletal framework of the respiratory system, which involved your vertebral column, your rib cage, your sternum, your pectoral girdle, and your pelvic girdle. We talked about the respiratory passageway, which starts at the trachea for the respiratory system, divides into bronchi at the carina, then the bronchi splits into secondary and tertiary bronchioles, ends in small air sacs called the alveoli. The alveoli are inside the lungs. Okay. Then we talked about the muscles of expiration and inspiration. The muscles for inspiration, the primary muscle for inspiration, an unpaired muscle, is the diaphragm. It's a dome-shaped muscle, and that's the only muscle, I cannot stress that enough, that's the only muscle that contracts during inspiration for quiet breathing. And during quiet breathing, expiration is a passive process. You do not need any muscular work. Then we talked about another muscle of inspiration, that is the external intercostals, which runs between the ribs, and is also important for muscle of speech. And then we talked about some accessory muscles of inspiration, which includes the sternocleidomastoid and scalenes, which are neck muscles. Then we talked about pectoralis major, pectoralis minor. Then we talked about the serratus anterior, serratus posterior superior, and latissimus dorsi. The serratus posterior superior and the latissimus dorsi are back muscles. Then your expiratory muscles involve the internal intercostals, the abdominal muscles, which are four: the rectus abdominis, the transverse abdominis, the external obliques, and the internal obliques. Then the quadratus lumborum and the serratus posterior inferior. Okay. Now, having talked about all of this anatomy, why is it important to understand how the breathing is involved in speech? So remember we talked about quiet breathing. Now we're also going to differentiate how quiet breathing is different from speech breathing. In quiet breathing, there is a degree of automaticity, right? Your quiet breathing is automatic. And remember, as I said, the only active muscle for quiet breathing is the diaphragm. Your exhalatory process is very passive process. But for speech breathing, you need more air, so which means you have to breathe in air to have to produce long uninterrupted utterances. So if I take air and if I don't take sufficient air, I won't be able to talk a long sentence in one breath. And that means if I don't do long sentences in one breath, you're probably going to hear a very broken down speech, so I would be able to get in sufficient air. Now think, for example, if somebody has a compromised respiratory system, right? If they have a compromised respiratory system, their symptoms that you can see in terms of speech is very small words or less words in one breath group, or they'll be short of breath, that is, they'll be gasping for air to finish a sentence. The other thing that also I want you to know is that when you talk about respiration, a respiratory cycle consists of one inspiration and one expiration. So you need to inspire and then expire. That is one cycle of respiration. In a quiet respiration, this one cycle of respiration, you spend 40% of the time on inspiration and 60% of the cycle is spent on expiration, meaning you're spending a little longer time on inspiration. But if you're talking about speech, you're only spending 10% of the cycle or 10% of the time of the cycle in inspiration, but 90% on expiration. So think about this. If you are wanting to, in your speech that is comprised of 10 seconds, if you spend 4 seconds on breathing in and 6 seconds to talk, every 4 seconds you're breathing in, which creates a silence. And 4 seconds is long, so it is 1, 2, 3, 4. That's 4 seconds. So if you paused for 4 seconds, imagine how disrupted your speech will be. So in order to have a good continuous speech, you have to produce, your inhalation should be very quick. So you only spend 10% of your respiratory cycle on inspiration and 90% of your respiratory cycle towards expiration, meaning you use a lot of your expiration and you talk on exhalation. So there are two differences right there for quiet versus speech breathing. So first difference is that quiet breathing is very automatic. and the only active muscle is going to be the diaphragm. While for speech breathing, you need to inspire more air, so you need to think about the inspiratory process. Next thing is about the cycle, respiratory cycle. 40% of your time in the respiratory cycle is spent on inspiration and 60% is spent on expiration. While for speech, you only spend 10% of your respiratory cycle on inspiration, while 90% is spent on expiration. And that is how you have a continuous speech pattern. So you won't have these breaks or frequent pauses, but you'll have a continuous uninterrupted speech if you have that quick breath and long exhalatory period. Okay. The final difference that we're going to talk about, we said quiet respiration, the expiration is a passive process. But what happens during speech breathing during expiration? We all know, or at least now you know, that we talk on exhalation. That is when we breathe out air, that is when we speak. So, how do we control this air? Because when we breathe out, we can breathe out this air in one gush. How do we prevent this breathing out of air in one gush but control the speech, control this regulated or regulate the airflow so that we can have a very regulated speech? So in order to do that, we have something called the checking action. What is checking action? Checking action is the activation of muscles of inspiration. Remember this. Checking action is when you contract or activate the muscles of inspiration during expiration to regulate the flow of air. Okay, so for example, I can go 1, 2, 3, 4, 5, 6, 7, 8. Right? That was all in one breath that I just had to gush it out. But if I go, and when I do this, I go 1, 2, 3, 4, 5. See, I'm regulating that airflow to be able to get that speech. Instead of just letting it out quickly, I'm controlling how fast or how paced my airflow is by contracting the muscles of inspiration during expiration. Remember, if you remember when we talked about the muscles of inspiration, I said external intercostals and serratus posterior superior are two muscles that are used during speech. Those are primarily the muscles that get activated during expiration to regulate the airflow. Okay? So, remember this. For speech, in order to produce speech, we talk on exhalation. In order to make an uninterrupted flow, one, we spend 90% of our respiratory cycle on exhalation. Two, we have to contract our muscles of inspiration during expiration to regulate the airflow. So that is how checking action is defined. I really do want you to know how to define checking action. And I do want you to know what are the differences between quiet breathing and speech breathing. That'll be an important question for you, okay, during your midterms. I really need you to know those two. All right, we're gonna just take a break here. I will record phonation later, but I want you to just think through this. That is one of our primary systems involved in the speech production process.